In section 6.5, we'll see 4 more ways to set up proportions inside of triangles. So these are all proportionality theorems. So here is theorem 6.4, the triangle proportionality theorem. If a line parallel to one side of a triangle intersects two other sides, so you can see here in the diagram, TU is parallel to QS, then it divides the two sides proportionally. So that would mean that RT over TQ would be equal to RU over US. Theorem 6.5 says it's the converse of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, so if you know that RT over TQ is equal to RU over US, then it is parallel to the third side. So then you'd be able to conclude that this line is parallel to that line. We would also know that their contrapositives are true. So let's first review what contrapositives are. Remember, in a contrapositive, you flip the hypothesis and the conclusion around, and you also negate them. So when an if-then statement is true, its contrapositive is also true. So the contrapositive of theorem 6.4 is, if you know that RT over TQ does not equal RU over US, then you know that the two lines are not parallel. And the contrapositive to theorem 6.5, if you know the two lines aren't parallel, then you can automatically conclude that the sides are not proportional. Let's put all of this to use. Here's example number 1. What is the length of segment MR? So we're looking for this length right here. The first thing I notice is that this line is parallel to this line. So I know that this length over this length is equal to this length over that length. So I would set up x over 12 is equal to 15 over 20. So cross multiplying, I would end up with 20x equals 180, and then dividing both sides by 20, I would end up with x equals 9. So MR would equal 9 units. Now let's look at example number 2. Determine whether segment PS is parallel to segment QR. If PS was parallel to QR, the ratio of 90 over 50 would be equal to 72 over 40. But at this point, I don't know if it's true, so I put a question mark. One way to see if the two ratios are the same is just to put each fraction into lowest terms. So 90 over 50 would simplify to 9 over 5. However, you can also check to see if the proportion is equal just by cross multiplying. If I take 90 times 40 and 72 times 50, if those two products were the same, then I know that this ratio is actually equal to this ratio. So 90 times 40 is 3,600, and 50 times 72 is also 3,600. So since I cross multiplied and got the same number, I can conclude that 90 over 50 is equal to 72 over 40. So since this proportion was true, then I can now conclude that PS is actually parallel to QR. And now we have 2 more theorems. Here's the first one, theorem 6.6. If 3 parallel lines intersect 2 transversals, so we have 3 parallel lines with 2 transversals, then they divide the transversals proportionally. So if you see here, that would mean that UW over WY would be equal to VX over XZ. Our next theorem is theorem 6.7. If a ray bisects an angle of a triangle, so you can see here we have a ray bisecting this angle into 2 congruent angles, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other 2 sides. So that would mean that AD over DB would be the same as CA over CB. In the next examples, we'll put these 2 theorems to work. So here's example number 3. Using information in the diagram, find the distance between First Street and Main Street. So here's First Street and Main Street. We want to know the distance between those from here to here. So if you notice, we have 3 parallel lines cut by 2 transversals. So that means that 160 over 320 would be equal to this length, x, over 340. So after I cross multiply, I set up my equation. 320x equals 54,400. So now I would just divide both sides by 320 and get x equals 170. So that means that this length right here from T to U is 170. So the distance between First Street and Main Street would be 170 plus 340. So I end up with 510 meters since we are working in meters. And finally, example number 4. In the diagram, angle ABD is congruent to angle CBD. Use the given side lengths to find the length of segment DC. So we start off just like that last theorem stated, that if we have a ray bisecting an angle, it divides that segment in such a way that it makes the ratio of this side over this side equal to this side over this side. However, we don't know the length from A to D, but we do know the length from A to C is 40. So I can state that this length is 40 minus x, since we know that this side is just x. So again, we know that this is 40 minus x. So to set up my proportion, I would take 40 minus x over that other length of x and set it equal to 24 over 32. So when I cross multiply this time, I have to realize when I take 32 times 40 minus x, I have to put the 40 minus x in parentheses. So I'd end up with 24x equals 32 times 40 minus x. So the first thing I would do is distribute. So 24x equals 1,280 minus 32x. I would then add 32x to both sides and end up with 56x equals 1,280. When I divide both sides by 56, 22 and 6/7. So about 23 units long. That's it for this section. Jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.